It's
Oh yeah,
right.
yeah.
All right. Relational substitution. Turn to page 285.
Which one?
Black book, binder, whatever the hell. If teachers made decent money, being a teacher would be a great job. I would like it a lot.
If I played some music right now, would
What
you
page?
bust a move?
No.
Oh.
I would ask you, like I do every time, what the hell's wrong with you?
It's a valid question.
285.
Oh, shit.
So, relational substitution versus value substitution. The substitution we've done so far has been value substitution. What that means is you plug in a value and you see if it works. Right now we're going to do relational substitution. We're trying to find the correct relationship as opposed to trying to find an actual value. Does that make sense? All right. So if you look at the example 1A versus 1B. 1A is a value problem, right? It's saying some crap about a pie, and then it says that what's the value of B, right? That's a value problem. If you look at A2, same crap about the pie, but then it says in terms of P and B, how much did Samuel pay? So you're not looking for the value of a variable, you're looking for some sort of a relationship. Does that make sense?
Ooh.
What are
Yes
these
or no?
examples from?
From my mighty head.
Oh, okay.
I mean,
No, doesn't make sense.
it does or does not?
Does not.
Okay, do you see how in A1 you're looking for the value, a number value?
Mm-hmm.
And in A2 you're looking for some sort of a relationship. How do we express it using that using a variable? Excuse me, you're not looking for a number value, you're looking for the algebraic expression of some relationship. Maybe a relationship is throwing you off. You're looking for an algebraic expression. You're looking for something that it's not telling you the actual value. It's saying, well, this thing in terms of P and B can be expressed this way.
So it just wants you to find the expression.
Right. But there's different ways of doing it. So flip the page to 286.
76.
What?
276?
286.
Oh,
And one of this has been making sense for you.
okay. Yeah.
So, look at B2. They want to know what percent of something happened. Now, a percent is not, even though you might think it is, a number. A percent is a relationship. A percent is the relationship between the part and the whole. Right? They're asking for a relationship. Finally, if you look at C2, if 9 minus A is positive odd integer, then which of the following must be false? They're not looking for a value, they're looking for some statement that's false. All right? So the whole key here is they're not looking for an actual value, they want you to determine something about these different expressions. All right? Make sense?
Yes.
Okay, so the tricky part to these is you are going to have to plug in your own numbers because they're not giving you numbers to plug in. But if you learn to do this properly, it makes life a hell of a lot easier. So we are going to start with the easiest ones to do, which is if restriction, then which substitution. Turn to page 295. So these ones are going to give you some restriction on a variable and then say, okay, then which of the following must be true or which of the following must be false. All right? So if you look at example A, if y is a positive odd integer, then which of the following must be true? Or look at B. 0 is less than A, which is less than 1, which is less than B, then which of the following has the greatest value? Blah, blah, blah. You all have seen problems like this on the SAT, correct?
Yes.
Where they set some restrictions on a variable. Okay. the key, the absolute key to understanding these ones is you don't have to make sure it works for every number that qualifies based on the restrictions. You just have to see if it works for a number that qualifies. So what that means is, in example A, where it says if y is a positive odd integer, then which of the following must be true? What you can do is say, okay, name a positive odd integer.
1.
1. Generally, you want to shy away from 1, just because 1 times 1, 1 to the power of 1, there's too many ways that 1 doesn't change. But yeah, 1's fine. 3 is a nice one, though. 3 is a great one to pick. So what that's saying is, instead of saying if y is a positive odd integer, you can say if y is 3, then which of the following must be true? You see how much easier this problem just became? Instead of it having to work for every odd integer in the world, you just plug in 3 and get rid of the ones that don't work. So let's look at A. Is 3 over 2 an integer?
No.
No. Gone. Is 2 to the power of 3 less than 2?
No.
No. Gone. Is 3 times 3 an even integer?
No.
No. Gone. Is 1/3 greater than 1?
No.
No. Gone. Is 3 plus 3 plus 1 an odd integer?
Yes.
Woohoo! How fucking easy did that problem just become? By saying, instead of saying y is a positive integer, you just say y is 3. As long as the number you pick fits, you can just plug it in and see which statement is true. Does that make sense, Mr. Bird? You see how easy these ones just became? Have these always been really hard before?
Yeah.
Right. Now they're just the easiest problems on the SAT. They're unfortunately not as common as I'd like them to be, just because they are so easy once you figure them out.
Yeah.
But you'll run into some. Now, here's the one thing to know. You may not be able to eliminate all of the answer choices just because you plug in 3, okay? So something might work for, maybe 2 of them work for 3, all right? So if that happens, try 5, right? Then, and you won't, once something's eliminated, it's eliminated, right? So just keep plugging in numbers till you've gotten rid of everything. One thing to keep in mind is you want to plug in a variety of numbers. So for this one, it's got to be a positive odd integer. So if you try 3, it doesn't work. You could also try 5, but then maybe try 101, right? Try a number that's really big. Okay, if they didn't have that restriction on there, you could also try plugging in 0 or 1. And actually one thing, McAvoy, about 1, it maybe shouldn't be the first number you try, but it is a nice one to try because it has some weird functions, all right? So if there are no restrictions, you would want to plug in a number, 0, 1, a negative number, a fraction, and a really big number. Not necessarily in that order or anything, but I'm just saying you want to plug in as great a variety of numbers as you can in order to try to eliminate all the answer choices. Does that make sense?
Yeah.
All right. So, one other thing to keep in mind about these problems that can ruin a lot of people is this. They might ask for which of the following is false, as opposed to which of the following is true. Anytime they say which of the following is false, the first thing you do is write a big ass false in capital letters right next to the problem. Write it down. Don't say, oh, I'll remember it, or whatever. Write it down. As soon as you realize you're looking for the thing that's false, write in big letters false. Otherwise, I promise you, you'll forget and fuck it up. Yes, sir?
Is it raining?
No, that's the heater.
Oh,
That would stink. Okay, does that make sense? Everyone, you good with that?
Mm-hmm.
All right, turn to page 299. Yeah, okay, we can do this one. So, if 1 is less than m, which is less than 2, then which of the following is the correct representation of the relationship between m squared, 2m, and the square root of m? Now, trying to do that by figuring out what's going to happen with a number between, forget all that. Just pick a number that works. So, And you can see they kind of did it on the way further down the page. Turn that so it's following me. So, we have 1 less than m less than 2. So what do we know about m?
It's in between 1 and 2.
In between 1 and 2. So what are we going to pick for m?
1.5.
1.5. And we want to know the relationship between m squared, square root of m, and what's the last one?
2m.
2m. So let's just figure out what each one is. M squared equals 1.5 squared, which is 2.25, correct?
Yes.
Square root of m equals the square root of 1.5, which equals 3 something? What is it?
Something.
It's some
Someone do it.
irrational number.
I don't think it matters.
It does.
Well, because look at the other
It
ones.
matters,
2m.
John.
Shut
It's
up.
math.
No, because
No, it matters because we could be doing it wrong.
1.224.
Okay, so here's the key. Never do math in your head. Okay? Always do it on the calculator. Always. Always, always, always. Okay? Because in this one it might not matter, the next one it might not matter. On that third one where you say it doesn't matter, it might. And that's going to kill you. Okay? It's only one problem, but those one problems add up.
yeah, I was just saying because 1.5 times 2m, you know it's going to be more than 1.
Yeah, that's
And
already
that
bad.
is
Probably.
1 anyways.
What I'm saying is, do the math. Okay? Just do it for this. But yes, you're right. 1.22 something.
Yeah, that's fine.
Okay. 2m equals what?
Right.
2 times 1.5, which is 3. So it goes, do they want least to greatest or greatest to, they're going least to greatest, right? So it's 1.22 is less than 2.25, which is less than 3. So we have square root of m is less than m squared is less than 2m, right?
Yes.
Do you see how much easier that is because we plugged in 1.5? Trying to figure that shit out. You could have figured it out. You could have realized, like, okay, if it's m squared, that's 1.5. That's something less than 2 times itself, which is going to be less than if I did 2 times that number. But why? Just plug in a number and then it's easy, right? All right. Now, turn to page 301. Do problem number 1. You can turn the camera on.